Hi guys, my name's Lindsay and today we're going to take a look at the definition of a logarithm. And the way that I'm going to talk you through that is actually by looking at the relationship between a logarithm and the exponential form. So let's take a look at an example that I've got written over here. So here I've got something that hopefully you're comfortable with. We've got 5 to the power of 2 equals 25. We've seen that before. If we want to put that into a logarithmic form, you can kind of see the format there, but let's take a minute and go through this. What I'm going to do is I'm going to write log, and then hopefully it makes sense that the base in this question here is the 5. The 5 is the base. And in a logarithm, here's the base right here in exponential form, the base actually goes down here. So I'm going to put that 5 down at the base of the log, and then I'm going to put the answer, the 25, after that. And the final answer to a logarithm is the exponent, the original exponent. And that's part of the reason that we use logarithms, because it gives us a chance to solve for an exponent. Let's take a look at another example. We've got 2 to the power of 3 equals 8. And if we wanted to write that as a logarithm, we could do it the same way that we did up here, write log. And then the base of 2. And then the 8 goes after that, and the exponent, that 3, is our solution. So now we've got log base 2 of 8 equals 3. And that's basically how you go from one to the other. Let's take a quick look let me write one here for you. Let's write a logarithm down, and I'll just use letters for this one. Let's do log base x of y equals z. If I gave you that logarithm and I asked you to put that into exponential form, what I hope you would do is you'd say, okay, the base is the x. So I'd put that x down there. My solution, or my exponent, is the solution. So I'm going to put x to the power of z, and that would equal y. So we could go from exponential to logarithmic form, but we could also go from logarithmic form to exponential form. So let me give you a second example. There, I guess this would be example 3 over here. So example 4. And let's see. Log base b of 7 equals 21. Now why don't you take a quick minute, pause the video if you like, it should just take you a quick second, and convert that logarithm from logarithmic form to exponential form. Okay guys, so hopefully what you did was you took the base, which is that b value, and then you took the 21, which is the exponent, and that would be equal to 7. Now that would be kind of a funky base to try to find, but hopefully that makes sense going from logarithmic to exponential form. And I'm just going to take a quick minute, make myself just a tiny bit more space here, and I want to talk about 2 more tiny concepts that go along with the definition of a logarithm. Okay guys, I'm back, and I just want to talk quickly about 2 more things, a common logarithm and a natural logarithm. So a common logarithm, I have an example here, basically is just a logarithm that has a base of 10. And we call it a common logarithm because it's used most commonly when you're dealing in logarithms. And because it's used so often, you'll actually often see a logarithm with a base of 10 written like that, where you don't see a base at all. And if that ever happens, if you run into a logarithm with no base, that just means that there's an invisible base of 10 in there. And actually, if you have a calculator handy, if you grab your calculator and take a look at it, you probably have a log button on your calculator. Just make a little room for the answer here. That log button is implied that it's common log. So if I wanted to find log base 10 of 3, I could do that in my calculator. So I would type in log of 3, not worrying about putting that base in. And if I wanted to round to, let's say, 2 decimal places, I'd write 0.48 as an answer there. So again, a common logarithm is just a logarithm with a base of 10, and we often don't write that base. And the second example I want to give you is a natural logarithm. A natural logarithm is a log, but instead of a base of 10, like the common logarithm has, it has a base that's an e. And the e value is actually a real value. Again, if you have your calculator, take a look. It's usually a second function button On mine, it's a second function button, so I'm going to press second function and press my E button. And if I just press equals, it'll show me my E value. And E is an irrational number. It goes on for quite a long, or forever, irrationally. But I'll round it for you. So E is about 2.718, although it continues on. So it's a real number. And because we use that one on a pretty regular basis as well, now we can't write log without anything and assume that it's an E, because we would assume that that was a 10. So what we've done instead is we've actually called the natural logarithm ln, ln. So ln is how you say that. So I could rewrite this log base E of 17 as ln of 17. That would mean the same thing. And in my calculator, again, I probably have a ln button, an ln button. So if I type ln 17, and I get my answer, I round it to 2 decimal places over there, so I'll do the same over here. I get about 2.83. So your calculator normally will have the functionality to calculate a common logarithm for you and a natural logarithm or a ln value for you. So hopefully that clarifies to you the definition of a logarithm based on exponential form and also what a common and a natural logarithm means.